Okay, so let's complete the discussion. Molar operator or scattering operator. So there, it's a very simple physical picture of the scattering theory, and you can have a physical understanding of the scattering theory by thinking in the following way, that you split the Hamiltonian into two terms. That is, the Hamiltonian H is can be split into H naught and V, where H naught, you can think about H naught as made up of is a free Hamiltonian, which is made up of two oppositely Hamiltonian for the two oppositely moving particles which are non-interacting, and we can consider as the interaction Hamiltonian. And for t is equals to plus minus infinity, the system is described by asymptotic states that evolves according to h naught, not by v, but that evolves according to h naught. And in between, the system feels the interaction and evolves according to the H Hamiltonian, which is the total Hamiltonian, that is the Hamiltonian H naught plus the interacting potential, which is V. Yeah. So the physical picture, the physical picture of a scattering theory uh, is that one can one can split the total Hamiltonian into two parts, into two terms, yeah. And that is basically H is equals to H naught plus V. So these are the two terms. That is a free Hamiltonian, i.e. a free Hamiltonian H naught and interacting interaction Hamiltonian V. Yeah. And for t tending towards plus minus infinity, the system is described by 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 an asymptotic state that evolves according to h naught, according to h naught. Yeah. And so this is an in between, that is the period at t is equals to 0. The system feels the interaction and evolves according to the total Hamiltonian. Total Hamiltonian H. So this is the two sort of parts. So uh, for example, we have uh, for example, two colliding particles, yeah, and interacting with potential with the potential V. Yeah. Then this is described by the total Hamiltonian then would be described by T1 plus T2 plus V12. Yeah. So T1 and T2. So T1 plus T2 is equals to H naught. And so we have the total Hamiltonian again, H is equals to H naught plus V. So H naught is the evolution of the particle in the absence of interaction. Yeah. So the first term is interaction free, and the second term is the interacting term. So where H naught is the evolution of the particle in the absence of in the absence of interaction. So there is no interaction uh, when particle is revolving as per H naught. So now, according to quantum mechanics, uh, you know, time evolution, time evolution of a state is given by time dependent Schrödinger equation. Yeah. And so if you want to know the time evolution of a state, you solve the time dependent Schrödinger equation, and that is what you basically operate the state vector psi, which is equals to iota h bar d by dt into psi. And so Schrödinger equation is obviously a linear equation, linear differential equation. And so some initial condition is required, and with the help of this initial condition, this would give you a unique solution for the state vector. Yeah. Hence, hence the solution of above equation क्या हो जाएगा? That would be psi, let's say call it as r plus t, yeah, which is equals to u of t psi r, where psi r is the wave function at time r plus t, and psi r is the wave function at some initial time, let's say, where psi r plus t is the wave function at time r plus t, and psi r is the wave function at time r. Yeah. So टाइम आर, और आप कोई और भी सिंबल ले सकते हैं. सो द टाइम एवोल्यूशन ऑपरेटर is linear unitary operator, because we can go forward in time and we can go backward in time. So the time evolution operator is a linear unitary unitary operator. Therefore, therefore satisfying satisfying the composition rule, composition relation. And what is that composition relation? u t1 plus t2 is equals to ut1 and ut2. So, and so from the unitarity, yeah, and the composition rule or composition relation, one can relate the evolution of positive times and negative times. Positive times and negative times का मतलब है t is equals to minus infinity and t is equals to plus infinity. So you can relate the positive times and negative times as ut dagger is equals to ut inverse. Yeah. So if you substitute the wave function, substituting the wave function in Schrödinger equation, so you would have h u of t psi, which is equals to iota h bar d by dt of u of t into psi. And this is in fact nothing but du of t upon dt, which is equals to minus iota over h bar and h u of t. And this comes out to be, if you remember, this is basically u of t is equals to the exponential function, which is minus iota over h bar h into t, yeah, which is the time evolution, for the interaction Hamiltonian, that is the total Hamiltonian, which is the time evolution uh, operator for the full Hamiltonian, for the full interaction Hamiltonian, in Hamiltonian. Yeah. Similarly, time evolution for corresponding to the free Hamiltonian, वो क्या हो जाएगा? Time evolution operator corresponding to the free Hamiltonian, that would be, u naught of t, which is equals to exp of minus iota over h bar h naught t. Okay? So these are the two. Therefore, the molar operator क्या हो जाएगा? Therefore, the molar operator would be किसके बराबर? This would be omega plus minus limit t tends to minus plus infinity u dagger of t u naught of t, and so this is plus minus, which is limit t tends to minus plus this quantity exp, and u dagger of t would be माइनस था उधर, तो ये आयोटा अपॉन एच बार हो जाएगा प्लस में एच टी, एंड यू नॉट ऑफ टी जो है एक्सपोनेंशियल, दिस इज बेसिकली माइनस आयोटा ओवर एच बार इंटू एच नॉट.